Hi, everyone. Thanks for joining in Technology Envoy. Today we have Lacey Clore with us, and we have a very special guest who's returning. This is our fourth interview with Chris Beskar, the CEO of Stavatti Aerospace. So hello, Chris. How you doing?
Pretty good. How are you?
We're doing great. We're doing great. Yeah. Thank you for coming on again with us.
Well, thank you for having me. I really appreciate it.
Yeah.
Yeah.
So, So Lacey has prepared some slides with some questions and whatnot about some of Ken Shoulders' work and whatnot, and some airplanes and that. So we'll just kind of get
Yeah.
going with it. All.
Mhm.
hmm Yep, I will share my screen.
Okay.
So this is a letter from Richard Feynman to Ken Shoulders on January
Oh,
31st of 1986. It says, Dear Dr. Shoulders, when you were in my office, I could not see how 10 to the 10 or 10 to the 11 electrons could be kept as a ball in a vacuum without ions. So I was skeptical and didn't let you tell me about them. I must apologize, for it has come to my attention and that it is indeed possible. In a uniform magnetic field, a group of electrons rotating at the Larmor precession frequency feel from the point of view of an observer rotating with them a force toward the axis, which would in size be equal to the centrifugal force expected from this rotation, but directed inward. Then an electric quadrupole could be used to hold them by repulsion along the axis, as long as the force away from the axis generated by the quadrupole does not exceed the previously noted confining force from the magnetic field. By adjustment of the size of the quadrupole field, and the forces of confinement can be made equal in all directions, just as if there were a density of ions in a vacuum and a rotating sphere of charge is possible. The size seems to be governed by the electric field available without breakdown, but it looks like a reasonable possibility is 10 or 2 times 10 to the 11 electrons in a magnetic field of several hundred Gauss. Now that I understand how it might work, I should be glad to discuss it again anytime you wish. My informant was the physicist Curtis Mitchell, who told me that ions were confined this way at the Bureau of Standards. Ions are easier. The electric field needed is less, and B can be raised to, say, 15,000 Gauss. Some work of this kind was started 10 years ago at UCSD by a Professor M. I forget the full name, but at first the phenomena seen were not understood. I again apologize for my skepticism, which prevented me from hearing about something very interesting. Sincerely, Richard Feynman. And we just kind of wanted to ask you what your were on this.
that's pretty much one of the coolest letters around. I mean, my goodness.
No kidding,
Uh,
right?
if that's not like the silver bullet letter from Richard Feynman to Ken Shoulders saying you have something here, I don't know. I don't know how much better it gets, really.
Yeah,
Um,
yeah,
so
exactly.
yeah,
Mhm.
this is what more can you say? I mean, it's pretty much self-explanatory, and it's just kind of goes to show that just because you may be a brilliant physicist working at Caltech, you might not necessarily be up on everything, and there can be work that has been ongoing for years that you may not be aware of, and that's really good to hear. And it's just a really neat exchange, and
Yeah,
wow, certainly shows the humanity of both individuals and the reality of what's neat. Now, this, of course, was written back um, when he was with the Institute for Advanced Studies in Austin, Texas. That talks, I think, you also this ties into the Jupiter Toy Company, to which many of the patents were assigned
right.
for Ken Shoulders, and so that's great. I would say that this is certainly something to encourage anyone who's working in this field that they could be on the right path. Mhm.
Yeah, charge clusters, right? It's
Right. Yeah.
Yeah.
yeah, that's what it's all about. Yeah, interesting because I sometimes call Lacey the charge cluster girl.
Yeah.
Oh yeah, this is really neat. And of course, Ken, he did a tremendous amount of work in this field, and to get this kind of letter of support, it would be interesting to see. I don't know if there was any follow-up information. You had brought up Pete Peterson earlier, and he had
Yep.
had dialogues with Richard Fenman about a variety of things,
Oh,
and so
wow.
this is and Ken Shoulders, of course, and all of that. So it does, kind of complete the circle. So
Yep.
it's not
Yeah.
not a surprise, but it's neat. It's a very good letter.
Yeah, it's like you said, if it's like the silver bullet or what, basically, right?
Hmm.
Yeah, it's very cool.
Yeah. Yeah, and I'll go over to the next one. This is by Adamenko from the Proton 21 lab in Russia. We believe that it was a black EVO that was shot into a 99.99% copper slug, and
Mhm.
transmutation occurred, and we think it was a white EVO that came from the transmutation. We do know that the transmutation process did occur because of what we see with all of these new elements that are being shown from the microanalysis.
Mhm.
Can you just talk a little bit about this process and how everything works here?
Well, what's neat about the EVO technology is that there is this transmutation element. And one of the big issues we were looking at, and Ken was looking at, and everybody who's involved in this is looking at, is using this as a mechanism to transmute radioactive elements, like radioactive waste,
Yeah.
into less radioactive elements or non-radioactive elements or isotopes.
Yeah.
So it's really a mechanism to accelerate the decay chain. Maybe that's the easiest way to put it, like
Okay.
Mm.
to get you where you want to be quicker as far as the whole decay chain of isotopes. Now, when you get into the issue of like uh, serious transmutation of one element into another element, um, EVOs, it's possible to do that, and the question is the expense involved due to the cost of having your particle accelerators and that sort of thing. The transmutation process of bombarding one element with either a neutron or a proton to result in something different.
Yeah.
That's very achievable. One of my favorites is bombarding bismuth to create polonium-210.
Oh,
And
Mm.
that's a neat reaction that then results in a radiothermal isotope that you can use as a heat source
oh,
or
wow.
a radiothermal generator. Now, to be able to achieve that without neutron bombardment is, fantastic. Essentially doing it with a electron bombardment, and so there's certainly an approach to that. The question is, do you transmute the nucleus in this process? And
Great.
uh, that's really pretty. Um,
So would we be correct in assuming that it was like a black EVO that was shot at the copper and it transmuted into a white? Is that sort of the way that it goes, or
well, I don't haven't really gotten into calling them black or white EVOs. Um, I
okay,
just kind of consider them to be EVOs in general, and the but I'm but yeah, I would certainly say that you can use EVOs for transmutation. I know Ken has written papers about that.
yeah,
And his emphasis again was really upon nuclear waste remediation.
great.
Mm.
And I think I've heard you say to me in the past that you could do that as fast as 48 hours with this technology.
Yeah, that was some of the work that was done, and so it is a very rapid process. I mean, in under a week, you can transmute reactive materials, and this gets into one of the political issues because the storage and handling of nuclear waste has become such a big deal,
Right.
and it's follow the money path, and there's been so much money invested into Yucca Mountain and things like that.
Yeah.
and to be able to come out and say, well, nuclear waste really isn't a problem, that we have technologies that, mitigate that. So let's just move on. Um, it kind of upsets the apple cart of the energy industry. But of course,
Yeah.
the EVO technology kind of upsets about 10 or 20 apple carts.
Yeah,
Yeah.
exactly. That, and
So,
I think that's the whole purpose here, right? Is to
Yep.
upset the
yeah.
apple cart. Yeah, which is what you're doing tremendously with all of your technologies coming out of Stavatti. Yeah, yeah,
So yeah,
amazing.
that's well, yeah, especially with energy, or and what Ken did is he and I think I've shared with you all the papers that I had, and Ken would just write these papers. Will this achieve levitation? Will this achieve anti-gravity? Will this achieve you know 0 point energy? Can it be
Yeah,
used as a weapon? Can it be used for manufacturing? He put out there's all these different applications for the EVO technology.
yeah.
It's really
And thank you for
great.
sending all those papers,
Yeah.
because that's something that Lacey and I are actually doing on Sundays in the physics group. Is we're going through and recording on YouTube all of that stuff, and that's where some of the black EVO and white EVO questions that we had
Sure.
sort of come from, essentially. Yeah,
Yeah.
yeah, it's amazing. Yeah, uh, it's fair to say that this technology is going to change the world, essentially.
Yes, without a doubt. And you hear inklings of it with some of the Navy patents that have come out, and you hear about it every so often, especially when people invoke the terminology 0 point energy. That's something that gets brought up. And what does that look like? What is that real
Yeah,
and really mean? So
and wasn't it Ken Shoulders himself that coined 0 point energy?
yeah, I believe so. That's what we've yes, from my
Yeah,
understanding. He was the first to really use it. And
yeah, that's amazing.
now
Yeah.
another story I heard is, and I think I shared this with you, that he was kind of one of the fathers of the microelectronics industry.
Yes.
Mm.
So that was, pretty early on. So he was always doing a lot of breakthrough stuff.
Yeah. Did he ever work directly with Pete Peterson, Ken Shoulders?
Yeah, I believe so, especially with respect to a lot of more practical things like he had a digital motor, what he called a digital motor, which was uh, essentially a type of what would you call it? He did different types of small engines that would use a single piston. It's like a free piston compressor. That's the terminology I was going to look for.
Free
So
piss. Okay. Yeah.
correct. So that's something where you don't necessarily have a crankshaft connected to a piston assembly. Instead, it kind of bounces back and forth in the tube. You have like a double-ended piston going back and forth through a cylinder. And so
Yeah.
one cylinder would be used for actually getting the piston to function. You'd have your detonation, and that would cause the piston to move. And then on the other end, you have the piston doing some compression work. So for pneumatics or for the
Yeah.
production of something fluid flow, that's where you would get into your free piston compressor. And it has, only one moving part, and it's very simple. And you can make little motors that use this that could be used to drive, say, a rotor blade pneumatically or other systems pneumatically. So
Oh,
it's very
wow.
lightweight and very high compression, very high speed too. So these could be diesel engines, so to speak, that use
Yeah.
different fuel sources. So that was where they had spent a lot of time in making micro, uh, operating flying machines and other devices. And of course, the value of the free piston compressor is you can make it very small, tiny,
Right.
like super tiny. So that's
Yeah. Yeah.
neat.
I took a whole bunch of hydraulics, so I get the understanding of the dual piston, like one's pushing and going back and forth. Yeah, and I think you actually gave me that paper. We just haven't gone through it yet
Yeah.
in the group.
Yeah,
Yeah.
he has a digital engines paper, and
Yes.
we expanded on that further. And there's even some, uh, devices we can produce that are based on that technology. One of which was the Shadow, a little micro UAV that he had
Oh,
put together.
wow.
It's
Yeah.
pretty cool.
That sounds cool. I can hardly wait to
That's
dive
really
into
cool.
that. Yeah.
Yeah, I don't know if I shared with you that paper. I think he mentions it in some of the works that I shared, but then we expanded upon that. And we proposed some of these to some different countries, and it's a small drone. And now I mean, this is way before drones were even discussed. This is
Yeah.
back in the 80s, really.
Oh,
Around
wow.
the same time that that paper came out, 80s and 90s is when we're talking about a lot of the drone work that he did. And so these are very small drones. I mean, the smallest was like a leaf that you could use to actually create a little spy device. So one of the things he was
Wow.
noted for is creating these micro flying machines that you could fly into environments and spy for intelligence operations, that sort of
No
thing.
way. Wow.
Yeah,
Wow.
that's you'll see that in some of the documentation, and so you find out that well, he was working for Stanford Research Institute, and
Yeah.
that tied into the intelligence community, and of course Hal Puthoff was there. That's where they were doing a lot of their
Right.
work on ESP and well, remote viewing, that kind of stuff.
Yeah, exactly. Yeah, remote
So
viewing. Yeah, using your consciousness to do things. Yeah, very
so
cool.
this whole thing is a big circle of intelligence community and advanced research projects for everything from, you have the Stanford Linear Accelerator, which is a very large particle accelerator,
Yeah,
to work for the intelligence community, DARPA, other things like that. So other agencies.
right. Yeah, very cool. I think Lacey's got another really interesting question that goes back to the
Yeah.
EVOs again.
Yes, and it does kind of go back to transmutation as well. Um,
Yeah.
we understand how this black hole or a
Mhm.
singularity causes destruction, and this white hole is
Okay.
creation.
Mhm.
How do these relate back to EVOs, and how is the transmutation process occurring in this specific scenario?
Wow. Well, so the EVO, that's your charge cluster effect. And so is that actually distorting the near space, I guess, is kind of the best question to ask it. And so that black hole there, that's fascinating. So were you is the thought that that is the black EVO, or is it something
Yeah,
else?
Yeah, that's what
yeah,
we're wondering.
Okay,
Yeah,
yeah.
so that's what you're wondering. Yeah. My goodness.
and this is a screenshot that I'm pretty sure I got from David Wilcock and your conversations, like in the past, on the
Okay.
disclosure, I believe. Yeah,
Sure.
yeah. So yeah, is there a transformation occurring between the black and the white hole at some point?
Yeah.
A transformation of materials or the change in well, okay, so this gets into the whole question that Ken had raised about whether or not this is actually able to distort space-time, and is there such a thing as a micro black hole that we can create?
Yes, yeah,
And so, you know, I don't know. I haven't done this experiment. I'm not sure if that is really a space-time distortion.
right.
Uh, but he purported that it could be, and this is where you get into the whole issue that Ken raised about uh, EVOs being a pathway towards uh, interdimensional travel or UFOs. The issue with the whole UFO phenomena is they occasionally just disappear.
Yeah,
And what is that disappearance? And is this actually a type of transportation? Is it going into a different dimension?
Mhm.
And
yeah,
it also brings up the idea of portals. And so this is just beyond a transmutation of elements.
right.
Mhm.
It's actually affecting space. And there's kind of two big views of the universe. One is that these massive things like black holes and space phenomena, large space phenomena, cannot be replicated on a small scale.
Right.
That's general view, that it's massive, it requires tremendous amounts of gravity, that only a collapsing star will achieve anything like this.
Yeah.
The other aspect is the thought that there are subtle energies in the universe. And that's really where the 0 point energy idea comes from. It doesn't come from, but it harkens to that. It's that there are subtle energies in the universe, and that you're able to do amazing things without a whole lot of juice, without a whole lot of power.
Yeah.
And so what they're doing here is not, I mean, these are not multi-megawatt reactions. These are, pretty much tabletop demonstrations that end up achieving something that could be really remarkable. And even when you look at, alleged flying saucers and things like that, small spacecraft, these are not big devices. These are, within, a physical reality that's pretty tangible. We're on the order of 20 to 100 feet. They're not that huge.
Yeah.
How do you generate energy? How would you generate the levels of energy needed to traverse the universe? Especially maybe you don't need to. And so what's neat is that this may be a doorway into that. Of course, I don't think from this setup here they have the ability to measure, any distortions to space time or anything like that.
Right.
Be good to repeat this experiment with, a full-blown astrophysics oriented laboratory with proper meters and measurement devices.
That brings up a great point, because this is something that perhaps maybe we should try at some point. Lacey and I were thinking about that. Yeah. So recreating the experiment. So getting your input is fantastic, Chris. That's amazing. Yeah. So yeah, could it even be teleportation is kind of what you're saying also, I think, eh?
It could lead to technologies that could result in the teleportation. Maybe.
Yeah.
I'm not gonna say it's not. I mean, I don't, are these, I mean, clearly you have something black floating there. Is that actually a hole in space time, or is that something else? Is that a charged object that is just absorbing everything around it in terms of light? And if that's the case, either case is really pretty neat.
Yeah.
The luminous part is pretty easy to understand conceptually. You're just like you're getting the charge clusters will produce this luminous
effect.
output. Yeah, this effect. It just does.
Yeah. Wow.
Yeah.
I think Lacey's actually got another question on this as well, that it kind of might relate, it might not. It's just something she observed. This is absolutely amazing.
Yeah, so I was looking at this, and I noticed these rings right here that are kind of coming off of it, and we see the same pattern on the WR-140 star. And I was wondering if you knew, like, if these two kind of like related. I know you were kind of talking about kind of like the subtleties and stuff, but how does this what is going on here, and how do they kind of relate to each other? Because it kind of seems like something's going on with both of them.
Well, I think when there's observational effects, like when you do any type of physics experiment using a splitter, and like a laser beam with a beam splitter, and you can get, different diffraction patterns and wave patterns. And I think that's more what we're having here on the right-hand side, that we're dealing with something that you're seeing light coming through gases and other materials that are acting like a splitter. That said, and on the image to the left, you're getting into well, I don't necessarily know if it's a camera distortion effect or if that's actually a visible effect. Now, in the case of both cases, if it's not distortion and not cameras, and if it's not, gases, causing some diffraction, and this pattern, well, then, yeah, it could potentially be some effect caused by the reaction. Now, here we have a star, and I don't think the star is doing any charge cluster type activity. It's probably just a star.
Yeah.
But in the same sense, you're getting, there's just these kinds of patterns based on how it propagates.
Yeah, because I didn't even actually notice it until Lacey showed it to me and then brought up the WR140 thing. But it's diffraction pattern or interference pattern is
Interference patterns, yeah.
what I kind of understood. Yeah, so that's really interesting. So yeah, I think this could be an experiment that we might want to do in the future, and try and figure out how to get set up so that we can measure things the way that you think we should on the left-hand side there. That'd be kind of neat in the future to do.
Yeah. Yeah, and so now we're getting into kind of other kind of questions. I understand that the SM-36 Stalma program should be watched for the development of technologies that are going to fly the HoverCar. We wanted to just know, how are you on developing a prototype for the HoverCar?
Well, the two projects are kind of tied together from a technology standpoint in the propulsion system. And so, lately we've focused on just finalizing the SM-36 design. It's gone through a lot of different iterations, and it has kind of a long history, but we pretty much finished up the core shape and configuration about a month ago. As a fighter plane, we wanted it to there's some driving factors such as the weapons bay size and that sort of thing. So we finished that up, and we hope to have the new images and that sort of thing finished. But part of it is when we're or released. Part of it is the engine itself for that airplane is a gas turbine engine, and it's a little different because it's not just an engine that can shift between a turbofan and a turbojet, but it has a very large aft fan to it, which is kind of unique. There aren't too many airplanes that have aft fans. The Convair 990 did, and that's a fan on the turbojet itself. So you have an airplane that's intended to get better fuel economy while flying at speeds under, Mach 1. That's the whole idea. So it can loiter and have long range. And then when you need the speed, you sweep the wings back and you go faster. To do the vertical takeoff version, we're generating electricity using the engine, and that electricity is then used to drive our propulsion system for the vertical aspect. And that's using an inertial propulsion system, which is a mechanical approach to achieving vertical lift, or really lift in any direction. So this is really a mechanical system driven by an electric motor. That same approach is what we're using in the HoverCar. So what the HoverCar does is it's getting rid of fans and blades, and it's shifting more towards an inertial propulsion system that will allow you to have a directed force and generate propulsive lift without needing air. In the case of the Stelma, that's nice because we can put it strategically in different places in the airplane and allow it to lift vertically. Now, we could, ultimately use this as the main propulsion system, but for just a wide variety of reasons, we've left the jet engine in there, and the jet engine is both providing forward thrust as well as a degree of vector thrust, as well as power to drive the inertial propulsion. In the case of the HoverCar, it's almost more like a hybrid vehicle where you do have electric batteries, you have the inertial propulsion system, you have electric motors, but you also have some sort of primary generator, which can either be a engine that puts out about 500 horsepower. It could be a rotary engine, it could be a gas turbine, or it could be something more exotic, like a EVO generator or something else.
Mm-hmm.
So you could have one that uses traditional fuel. You can have one that uses the EVO technology, or one that uses like a radioisotope power source, or some small type of energy generation device. So we're looking at all of those different modes for propulsion, and it also translates into eventual aircraft propulsion. We'd like to phase out the traditional fueled jet engine
Yeah.
with something else. And that something else really gets into the EVO technology.
Yeah.
And it gets into other technologies too that aren't really EVO, that are not at all, but they're other methods of producing energy. So in that sense, the HoverCar really represents uh, a breakthrough energy product. But it's also, you can prototype it today using like a gas turbine engine to generate the electricity, drive the electric motors for the
Yeah.
inertial propulsion system.
Wow.
So I hope that kind of helps.
Yeah. So how far away do you think you are to public disclosure of the prototype and whatnot?
Well, we've got two neat things happening. We're doing kind of a closed inertial propulsion meeting on the 27th of this month of April to go
Oh,
over all of our different modes.
cool.
Then we're working on the airframe structure itself. So we're working on producing the airframe, and then we have test beds for the different propulsion systems. And some of that is coming out of the Stelma project. So the HoverCar and the Stelma can come out at about the same time. As a prototype, we're looking at about 1 to 3 years. We'd really like to get a prototype out as early as next year.
Wow.
Wow.
See, and it's not really for us, it's not a super expensive project. It's about a $5 million initiative, but the prototype itself isn't really that expensive. But then you get into, it's about, let's say, $1 million or less for the prototype. That includes all the machinery and tooling and stuff like that.
Yeah.
There's also a demonstration aspect of it, which is really bench testing the different propulsion methods.
Yeah.
All said and done, it's probably about a $500 million project. That's what we budgeted.
Okay.
But there's an FAA component certification aspect of it. There's, that includes a number of different things, including any self-flying technologies that get into it. If
Yep.
we have an artificial intelligence component,
Mm.
so there's a transformation of the project from a product or into a technology into a product. So that's part of it too.
Yeah.
So it's not, I'm not saying, hey, we got to go spend $500 million to get this thing to work. But all said and done, when you add up everything that led to the factory and led to the production costs and the tooling and setting everything up, it's about a $500 million effort.
Okay.
That will be probably funded. We have two phases for the program right now. The first phase, we're just funding through the investment capital we're raising through accredited investors and that sort of thing.
Yeah.
The other funding, and there is some degree of government funding that gets into that technology too, or customer funding, I should say.
Mhm.
The other funding for like the larger amounts to put it in production, that comes essentially from pre-order backlog financing. Like you secure a certain number of orders, it's on the books that you have paying customers, and so you're able to secure, essentially a loan from a bank like Bank of America or Deutsche Bank or something like that.
Yeah.
And you just complete your development and move forward. Technology speaking, there isn't really any technology problems.
Right.
Part of this whole approach is taking things that have been discussed in the aerospace defense and the UFO community, both of them, for 60 years.
Yeah.
And just finally doing something with it. And so this is not the first time we've encountered these kinds of technologies. I've been hearing about them my whole life.
Yeah.
And there are people that I know who have built a lot of different devices that fly that are unconventional. And,
Ooh,
uh, and so that's part of the reason we're having, this event later this month, which is, it's kind of another opportunity to say, okay, so here's all these different approaches to this same technology. Uh, so let's just discuss it and decide which ones we're going to focus on in addition to what we're focusing on. So,
yeah,
Yeah.
that's very cool. So is that like a meeting with the board of directors with Stavatti that you're talking about on? Or?
no, it's really a group of people that we've known for years and different other inventors. And where this comes out of is as soon as you mention you're working on something like this, you get all kinds of inquiries and phone calls and emails saying, "Hey, I've got a device that'll do such and such." And we said, "Oh, okay, well, how about we all just get together and see
Cool.
which we believe has merit and which don't, and we'll plop them all on the table together and say, well, this is what we're working on,
Wow.
and if you have a device, that can be licensed or can be produced or can be used, maybe you have a better approach. I don't know.
Yeah,
I have no
Wow.
idea. So it's kind of fun.
that's very cool.
Yeah. Yeah. And
Yeah, so Chris, thank you for sending these images before the show here.
Sure.
And I just wanted to talk a little bit about this. So this is the SM 940K refueling what I think is probably your favorite jet. I'm not sure. You could answer that question. But my question was, it's got some really interesting wing placement and also the way the engines are mounted on the refueling tanker there. So could you talk a little bit more about that?
Sure, I'd love to. So, the U.S. Air Force has had this continuous need to replace the KC-135 and to expand the tanker fleet, or just to continue the tanker fleet,
Yeah,
for a long time. And so we saw the KC-46 tanker be developed by Boeing, and the Air Force has acquired some KC-46s, but not as many as I thought they would, but forget what the number is to this day. But
yeah,
it's service and they're flying it. Um, I've had the good fortune of getting on a KC-46, so I know quite a bit about it. We have a lot of information on the KC-46,
cool.
and but there's still this need for the KC-135 replacement, and the KC-10 was just recently retired this past year. So within a year, it was retired. So back in 2024, I believe. So we have this need for a tanker, and the the SM 940K came out of this ongoing requirement for a tanker. And now there's this discussion of KCX and KCY, and so the conversation is sort of along the lines of let's find a new tanker to the KC-135. Now, there's a question if it should be a stealthy tanker or a more traditional non-stealthy tanker.
Oh, yeah.
And so Stavatti has two different designs. We have a stealthy tanker design, and then we have this tanker. And the KC or the SM 940K is our non-stealthy tanker, and it's part of our 900 series of commercial airliners.
Yep.
And so this design, it's based on our 940, which is our large wide body. It's kind of our 787, 777 Airbus A350 replacement.
Okay.
And we submitted this, I think, to the Air Force, gosh, I want to say 2 years ago is when we first announced it. And then I think about a year ago, we posted something on Twitter about it, or within the last year, I think.
Yeah.
And more recently, we really focused heavily on the commercial airliner area with our 920, which is our major project for commercial. It's kind of our major Stavatti project now. It's a
Oh, okay.
big program.
Yep.
So the 920 is our single aisle commercial airliner, twin engine, and the 940 is based on that design. Although the wings are less swept. I think they have 30 degrees of wing sweep rather than the 40 associated with the 920. So this is designed for a longer loiter. It's really more like a long-range Airbus A350. It will surpass the A350's capabilities by, say, a 10 to 20% order of magnitude.
Oh, wow.
So it is more efficient, yet it's larger. It's physically larger, not by that much, but enough that it's more comfortable. And part of the design idea and part of the problem we have in aerospace is to make long, skinny wings, which are more efficient, high aspect ratio wings. There's a structural issue with that. You make really long, skinny wings, they become a structural problem. And you also have less room for fuel.
Yeah, right.
So
Yeah.
we came up with this engine nacelle configuration, which is really it's a throwback to the engine nacelles found on the Concorde or the B-2 bomber, the B-1 bomber, where you actually put the engine in like a jet fighter nacelle, and you have a controlled system that you can manipulate the airflow like an air intake. And so you get an air intake system, you put the engine in, you have additional space for reduction of noise coming out of the tailpipe. So it has a longer tailpipe than you'd find on a traditional jet engine or jet airliner.
Yeah.
Plus we add thrust vectoring to that. So you get an airliner that benefits from some two-dimensional thrust vectoring. And so there's all these compounding things, and the nacelles themselves serve as additional fuel tanks. So you get additional fuel tank space despite having a long, skinny wing, and it's not in the fuselage of the airplane. It's like a fuel tank you might find on an F-16.
Yeah.
So the fuselage, I should say. So that's the key. And so this is our commercial solution as a tanker. And it's designed to refuel up to 3 aircraft simultaneously. The one presented has the single boom. So it's our big competitor to the Airbus multi-role tanking system. And but you know what's even more exciting is our stealthy tanker, which is it's not exactly a flying wing, but it's kind of a great big trapezoidal, you know, interesting shaped aircraft that we haven't seen publicly yet. But
yeah, that sounds really interesting.
Yeah.
How does the thrust vectoring work on that 940?
Well, you can see if you look at the engine nacelles, there's little these, you know, the image itself. If you look at the engines, you can see it has the lighter gray areas that are swept at the back of the engine nacelle. Mm-hmm. And so we have a splitter plate, and we also have these nacelles, and the nacelles move up and down, so they vector the thrust, and that splitter plate moves as well to help direct the thrust, and that can split open to serve as a thrust reverser. Yep. So it's got your thrust. It has the ability to direct the thrust up or down, really, and so you can add a roll component to this. It's kind of like the thrust vectoring system used on the YF-23. That's probably the best way I can compare it. But there again, it's also kind of like a YF-22. So you're sort of getting the best of both worlds.
Very cool. That's very cool. And is the SM-39 your favorite plane? Or what is your favorite?
It really is one of our favorites, and it's something we're very excited by. And of course, we show it being refueled in flight, and that's you know, accurate as far as dimensions and how the in-flight refueling probe can go in there.
And the SM-39 is going to be Mach 4 plus. Is that the?
Yes. Yeah, that's correct.
Yeah. Which is faster than the SR-71.
Mm-hmm.
I always say that the SM-39 looks like a more advanced SR-71, kind of, in my kind of view, because of the, you know, the way it's configured and everything. Very, very cool plane.
Yeah.
Yeah. So I guess this leads into this question. You pretty much answered it by saying that they're basically the same plane, except for this is the smaller version of it. But you can tell us a little bit more about this again.
Yeah, sure. This is our SM-920, which is our 204 passenger twin engine single aisle airliner. So it's like a 737 or an Airbus A320. It'll be produced in a few different fuselage lengths, but overall, the standard version is of 204 passengers in seats that are uh, a little bit better than basic economy. It's a
Yeah,
32-inch standard pitch, so it's a little more comfortable. It's designed to really be a comfortable airplane, so that was a key aspect of it.
yeah.
Started with the fuselage cross section, and it can hold LD-345 containers in the belly, which means it can haul containerized cargo like an Airbus A320.
Oh, wow.
And we're offering four different engine choices in this one, Pratt and Whitney or a CFM engine or a Stavatti engine.
Ooh,
And we also have another, and that Stavatti engine is based off of the aft turbine technology from the Stelma.
oh, cool.
And we also plan on offering a more exotic propelled version that will, benefit from our untraditional, non-conventional fuel sources. So
Yeah, very,
yeah,
very cool. Yeah, because I think I saw something on here that said it was like 20% better fuel economy than
yeah,
maybe 737. Is that right? Or something like that?
that's correct. Compared to many of the 737s, it has much better fuel economy, and it will be more efficient than a 737 Max or an Airbus A320 Neo.
Yeah.
So, and it varies, each of those airliners has its own particular fuel economy, but it gets from anywhere from 11% better fuel economy to almost as high as 30 if you're using jet fuel.
Yeah, yeah, exactly. And I can remember you actually sent me something that said, do you want to vote on my airliner
Oh
design?
yeah, yeah, right.
Remember that?
That was for the NASA technology. What was it, the oh I forget, that was their annual Create the Future design contest, I think. And so we submitted this as a company, and we, I think for the aerospace category, we won the best in class or either first or second place. I don't remember which, but it was
Wow, cool.
pretty high ranking. So that was cool.
Yeah, definitely, definitely cool. And I think Lacey's got another one here.
Mhm.
Yeah, this is the SM-150 civilian sport plane. Uh,
Yeah,
can you kind of talk about this one? And
sure.
is this a canard right
Yes, it
there? What's
is.
the
Yeah.
reason for that placement?
Well, this is really a general aviation personal aircraft. It's kind of your bridge between airplanes and hovercars in a way, but
Mm,
it will be produced with a propeller driven by either a rotary engine or there are also non-propeller models that we will offer uh, with a little jet engine, little almost like a
wow.
ducted fan, but not quite. So there's a lot of different configurations for this airplane. We're doing a vertical takeoff version of it that will
Yeah,
benefit from the same HoverCar technology.
yeah.
This particular airplane is designed as a light sport aircraft, which means it falls under the light sport plane category, and you don't have to be an FAA certified pilot to get this. You can fall under the
Oh,
sport plane category. And
cool.
so this version has a fixed landing gear and it has these, the landing gear doesn't retract. We will be making a version of the airplane that has retractable landing gear and a bigger engine and it will go faster. This is really limited by the light sport plane categories. So
Right.
it's kind of like a Cessna 150 or a Piper Cub. This model happens to be a tail dragger, so it's really retro in that sense for people that love tail draggers.
Yeah.
Of course, we got another version of it with the retractable landing gear that is really a quadsicle that will go faster and you can retract the gear and it's a more conventional tricycle gear type arrangement, although not it's a quadsicle like a B-52.
Yeah.
The canard is there, so we have really three flight surfaces, or four actually. We have the wing, we have a tail, which is at a V, so it's like a V tail that functions as a horizontal tail and as a vertical stabilizer.
Yeah.
Below that, below the V, you see we have little vertical stabilizers. So the airplane handles quite nicely and spins and stalls. That's the design intention.
Yeah.
And we've
Um,
we've demonstrated this. So to do this kind of airplane, uh, uh, we of course design it initially on by paper. I draw it everything by hand, and then we go
wow.
into the computer aided design. We
Yeah.
design it in SolidWorks and CATIA. Then we do CFD, computational fluid dynamics modeling. We
Yeah.
have a few different programs we use, but one that we use a lot is Stallion now. We're going through Stallion, and we like that a lot because it gives out lift coefficients and drag coefficients
Wow.
very easily. It's a very fast precision program.
Yeah.
Then we do some modeling and some different simulation programs to demonstrate that it flies, and then we build radio control models.
Oh,
And
cool.
they come in different shapes and sizes, and they fly, and we're happy about that. And so from all of our modeling and simulation, it handles quite well. The canards are there, and that it's a little bit different use of a canard than you'd find on a Burt Rutan airplane. While it generates lift and it's kind of like a biplane effect, it also helps really control the airplane and allow it to do some neat maneuvers. And so
Oh,
the overall goal is it's a very maneuverable airplane. It also can uh, handle stalls and spins and departures and allow you to recover very easily.
so it'd be a great airplane for someone that's just learning or just has got their license and that type of thing. So how much do you think something like this would cost?
Well, that's our $85,000 airplane.
Oh,
So
okay.
we're really focused on $85,000 or less. We'd
Wow.
like to make the light sport plane version more affordable. Um, we would ultimately like it to compete with, say, a Honda Civic, which is in the 25 to $30,000 range.
Yeah.
Uh, and I think we can achieve that depending on the configuration. Of course, ones with retractable landing gear and bigger engines, they'll be more expensive.
Yeah.
It's really designed to be something that's affordable to just about everybody, and you can learn to fly in it. And even though it looks weird, it's unconventional. It's intended to be very futuristic and inspirational.
It looks very cool.
Yeah.
You,
That could be the plane to start flying in, essentially.
Mhm.
Yeah.
Yeah.
Very cool.
Yeah. And we know that titanium diboride was developed for DARPA, and you also use it in your SM-39 plane. Can you talk about this material a little bit more and how it functions?
Sure. Well, so titanium diboride has been a material that's been pretty well known for a number of years. Uh, there's different universities that worked very heavily on it, such as Georgia Tech.
Okay.
Dr. Catherine Logan was one of the pioneers in this. And so I can't really recall where she received all of her different funding other than the university. I think there was NASA funding involved, and I'm not sure if there was DARPA funding. We submitted this paper that right here
Mhm.
to DARPA last year,
Yeah.
uh, following a meeting we had at DARPA headquarters in December. And of course, this paper it focuses upon the titanium diboride. It focuses upon foam metal sandwich technologies and other approaches to have very lightweight, high temperature aerospace materials.
Yeah.
So what's neat about the titanium diboride is it is a lightweight, high temperature metal ceramic that's perfect for aerospace, perfect for structures, skins, and of course, fan blades, turbine blades.
Yeah.
Because of the nature of the material, it's easier to make small components like turbine blades, for instance, than large sheets. And so a big part of the SM-39 project has been coming up with how you manufacture large parts using this material.
Yeah.
And so that's been an effort of ours. And so It's pretty exciting, and it's one of the best metal ceramics out there for high temperature, long life, durability, impact resistance. And you know, whenever you get into ceramics, there's this impact resistance aspect of things
Yeah.
that you need to be careful about. So this is really a metal ceramic. It's not just a traditional ceramic. So
And you're using it because the flying Mach 4 Plus is there's a lot of heat involved with the skin of the aircraft, so that's why you're using this material.
that's a big part of it. That and the strength to weight ratio, uh,
Okay.
the the stiffness, its electrical characteristics. Titanium diboride is one of these materials. We talked a little bit about superconductivity. There are superconductive aspects of the material at the right temperature. So,
Ooh, wow. That's interesting. Yeah. Yeah, being a ceramic, I could actually see that. Wow, very cool. Um, I did want to ask you a couple questions about your time with Pete Peterson and maybe Area 51, if there's anything that you can reveal.
Mhm.
any specific questions?
I guess I was wondering, I know that you approached the Air Force in grade 8
Mhm.
and then sort of worked on from there. And I know that there's a thing saying that by the age of 23 that you pretty much had everything that you wanted achieved. So what does that mean basically?
Okay, well, so the question comes up every so often: has Stavatti built an airplane? And this you
Yeah.
see in the media, and there's been articles. And the interesting thing is that usually these articles are written by people that haven't actually asked me the question. They've been
That's right.
repeating
Exactly.
they've they've been repeating this attack that actually came out of a blogger who may or may not have been working for Boeing when we were dealing
Ooh,
with the early days of the TX program.
wow.
And that gets into some interesting discussions, but we were going pretty intense head to head with Boeing on the TX, which was a trainer for the Air Force. And now we're going head to head with them on the undergraduate jet training system, for which they released the fourth or fifth RFI on Monday, the 31st. So we're going up against them. And so we're the underdog. Boeing has their T7 and we're offering our SM-31. But which hasn't been built yet. I mean, I'll openly state, no, we haven't prototyped the SM-31. We're working on that pretty intensely. And part of the issue, of course, is when you get into any kind of military aircraft, they get expensive pretty quick.
Yeah.
And it's not really something you can build in your backyard or your basement or in your garage. They require big facilities like the one depicted behind me. So we have a great big facility where we can build we can build our 920 airliner here. So it's a good size facility, and we have
Yeah.
space to do that. But so the other issue is, how do you define Stavatti? And so I founded Stavatti Corporation in 1994. And then we founded Stavatti Aerospace now, which is really more focused towards aerospace in 2019.
Oh, wow.
And the reason we did that was we wanted to have an aerospace only focused company, which Stavatti Corporation was getting into a lot of other things. But so we wanted aerospace focused, and we also wanted to allow it to go public, like have an IPO and
Yes.
have a clean sheet of paper and really focus more on commercial things. And so when you look at what Stavatti Aerospace is doing, like our number one project is this airliner. The other military projects are great too, but it's really more focused on the airliner.
Yeah.
And the airliner, coming out with a new airliner to compete with Boeing on the airliner front is not something that is welcomed. It should be, but it's just not the politically correct thing to do.
Yeah. Yeah.
Worse than competing with Lockheed on jet fighters.
Wow.
And of course, in the United States, there really isn't any other airliner manufacturer than Boeing. We used to have McDonnell Douglas. Lockheed used to build an airliner, the L-1011, but they don't anymore.
Yeah. Yeah.
You have uh, us getting in the business. And then you have other companies too, like Net Zero is another company that has a blended wing design. And there's another blended wing design company too. And they get the same kind of reaction. They say, they call us crazy because we want to build airliners. But there's a lot of need. I mean, right now the airliner market is tremendously huge. It's estimated at being a $4 trillion market over the next 20 years. It's
Wow.
Yeah, I mean, you have companies like Indiago Airlines in India that have ordered hundreds of airliners, and so
Wow.
so it's a big business, and so Stavatti Aerospace Limited of Wyoming, which was incorporated in 2019. No, it hasn't. Well, I should clarify that. Up until last year, it hadn't built an airplane. Now we're selling drones and things like that. So we are building flying machines, and you can order one today. So that
Yeah.
worry that we're not building planes is not true. But getting back to the early history, which really started in 1989, 1990, that's where we submitted an unsolicited proposal, and we received funding to build a flying machine, and it flew, and it was under a multi-role fighter program.
Wow.
And we have a military, you call it a special access uh, agreement that does not allow us to disclose certain things, but that was not under Stavatti Corporation. This was a predecessor to that.
Okay.
And so when you get into what happened with Stavatti Corporation, our program was under the multi-role fighter program. And there was an Aviation Week article about it. And they said that the Air Force funded a private initiative to build a prototype. It was a 1993 article, I believe. And but it didn't go anywhere. And so what happened with the multi-role fighter program? Well, it got canceled under the Clinton administration.
Great.
And back in the 90s, not without getting into all the details, you had a variety of projects that were in the Air Force and Navy that were supposed to happen. Like we had the AX, which was going to be the Avenger 2. That was the A-12.
Yep.
That ended up being canceled. You had a Navy Advanced Tactical Fighter, which was supposed to replace the F-14. It was either going to be like a Navy F-22 with swing wings or something else. That never happened. The Navy never got their F-14 replacement.
Yeah.
You were going to have an F-16 replacement by 1996, and that fell under the multi-role fighter program. And presumably, that may also replace the F-18. And so our focus was, let's build, I like to say it was an F-16 replacement. It was really more of an F-18 replacement.
Okay.
So we worked on that program. It got canceled, and then the multi-role fighter program became it started out, I guess, the Common Affordable Lightweight Fighter. Then it became the Joint Advanced Strike Technology Demonstrator. Then it became the Joint Strike Fighter. This is all over a period of time from about 1993 to 1996 or 97.
Okay.
Now, we submitted what we had done under the Joint Strike Fighter program. We wanted to be included in that. However, ours did not take off and land vertically. It was only a conventional takeoff and landing airplane, so it wasn't included in that DARPA program.
Great.
So in 1994, in response to that cancellation, I founded Stavatti Corporation. And the idea was we're gonna raise private money to develop this fighter further and get it into production commercially. Well, by the time we did all that, it became politically unpopular to challenge the Joint Strike Fighter program.
Wow. And
so we had submitted a letter to the Air Force in 1999. Well, actually, a request. Actually, let me back up a second. So the Air Force said maybe you can compete under EMD for the F-35, which will be free and open solicitation. But it wasn't. It was closed to Lockheed and Boeing.
Oh.
And so that ended there. So what we've done is we've taken this whole legacy and we've repackaged it and followed on. We've continued on for 20 years now, and it seems forever. And that led to our Stelma project. So we have a stealthy single engine variable geometry fighter with canards. And the reaction, it's a different approach to stealth. because part of the problem with stealth technology, like you have with the F-117 or the F-22 or the B-2, is it's very focused on specific wavelengths and specific frequencies.
Yeah.
And
Radar, yeah.
they use planform alignment, and they use these different approaches, which work, but they only work over certain ranges. And so if you want something that is more stealthy than a B-2 or a F-117, you need to take a different approach, and you need to focus more on electromagnetism. You need to focus more upon having an active stealth approach rather than a passive approach.
Yeah.
And so that was really the force of the Stelma project. And so that was, kind of that history. Well, then in 94, there was an intelligence agency that said, hey, we really like what you did with this project earlier. Could you do something for us which embodies some of those technology elements for what became high altitude long endurance?
Ooh.
So that's high altitude long endurance airplanes. So we kept busy with that for about a decade, and that remains classified to this day. There isn't too much I can say about that. So when you ask about like Area 51, well, what was done there? Well, that's where some of this kind of work was done, and the Tonopah test range. And so,
Gotcha.
that's where I became involved in those things from really 1990 through the early 2000s. And of course, Pete Peterson had some connections in that.
Yeah.
And he was a technologist, and part of that gets into material science, the scandium aluminum technology in particular.
Mm-hmm.
A lot of the composites, advanced basalt fiber composites, using a lot of the Hexcel composites like IM10 and IM9 fiber. We had we're one of the, and it's not always done through us. You use a lot of different other companies to keep certain projects secret. Like you'd have another company order parts for you and make parts, and they'd come into you, but you have a buffer company. And so through a buffer company, well, we were one of the first airplane companies to use XLIM9 fiber, which is a high performance, high tensile strength graphite composite material.
Yeah.
And non-carcinogenic composite material. So we learned a lot about composites. And that's why we're really shifting to the foam metal sandwich, because on a commercial level, composites are very good for special applications. But it's really difficult to affordably mass produce composites.
Right.
And it is just very challenging. So it's easier to make things out of metal, like hydropressing, and you can't stamp out composites like you can stamp out a car.
Yeah, exactly.
And this gets into the long discussion of why don't we see too many aluminum cars? Why don't we see too many composite cars that are mass produced by the automakers? And it's because, well, it's just difficult.
Yeah.
And so you end up with steel that's thicker and heavier, but you can stamp it out. It's cheap compared to other things.
So the SM-36 Stelma, is it fair to say that would have a double hull configuration? Because I know I've heard you talk about that.
Yes, you could say that it does. Some of the versions do. We have one version that does and one version that doesn't. And so there's kind of an export model and a non-export model. So we worked on the double hull version for about 20 years in the design. And recently we've changed it for a different mission, and it uses the big thing I should just explain is the Stelma was originally a composite airplane.
Okay.
It did have metal in it. It had some titanium and some alloy and stainless steel and some aluminum lithium, but it was very composite focused.
Yeah.
And that was in my early days. I was a huge believer in composites. I thought composites were the greatest things ever.
Yeah.
And so I was on that up until about really 2005 is when I started saying, hey, maybe metals can outperform composites. And we learned that they can, that there are metals that outperform composites. And it's not just a metal, it's using honeycomb sandwich or foam sandwich.
Yes.
So we really got into the foam metal sandwich world. So
Wow. Yeah, because I've heard you said once to me that of the four different ways we have to fly the HoverCar, that three are operational. And I was like, I know of two different ways to do it, but the third way I didn't, and the fourth one is like, whoa,
yeah,
right?
that gets into the exploration. So you're always exploring on different ways of achieving stuff.
Yeah, yeah, yeah. It's very, very cool. Yeah.
Yeah.
What else we got? Lacey, do you have any more questions for
Um,
Chris?
yeah, I was kind of wondering like what your like what is your favorite project of all time that you've done?
Hmm.
Yeah, like your most favorite, your prized possession.
That's a good one.
Yeah.
Well, the ultimate project is building the big spaceships, like your Star Trek, Star Wars level of spacecraft, and we haven't done that yet, but that's where we're headed. As far as the Stelma project was really cool. That's a really neat looking airplane. It's on iteration number 4, and the first one was probably the best because when it started out, um, it was just unabashed, uh, you know, drawings that I could be as creative as I wanted, and
Yeah,
that was neat, and it wasn't constrained so much, uh, and it was intended to be super futuristic, and it still is, and so. Now that I'm older, I'm 50 years old now, and you could say the weight of the world has, squished a lot of creativity. You kind of go, well,
yeah,
you're less creative, and so that was really creative, I would say. And the problem is that at the time, there are just certain technologies we didn't have, and today we do. So we're able to really implement what I wanted to see back then today, which is nice.
yeah,
Uh, but so the whole idea of a variable geometry compact fighter. But part of the problem with all of those things is airplanes, and this is common to airplanes. As you add more to it, they become bigger.
yeah.
And so the new Stelma is 57 feet long. The original was 47. It's become 10 feet longer. It's become fat and overweight, and it still looks
Yeah,
sexy and all that, but it's not as compact. And so the idea was make smaller, compact fighters with lasers. You don't need missiles anymore. Uh,
lasers.
yeah, lasers, big
Wow.
gas dynamic laser. The problem is that, and you see this now. I mean, there are. So I was and I got in trouble for this, talking about laser technology before we're supposed to talk about laser
Ooh,
technology, and that got me into a lot of hate and a lot of people not wanting stuff to come out. Well, now we have laser weapons. It's
yeah,
pretty, and we've demonstrated we have laser weapons, and you can put a laser on a plane or on a satellite and cook all kinds of stuff. And
yeah.
that's been happening more and more. But that said, so there's certain things that just aren't publicly available, but now they're becoming. I mean, if you don't know we have laser weapons, you haven't been paying attention very well. But all the big defense companies now have them, and Raytheon, even General Atomics is selling or marketing laser. I think they're selling it. I think they're definitely marketing it. So there are laser weapons on Predator drones and stuff like that.
Yeah,
Or they're marketing that there are laser weapons on Predator drones.
yeah.
Um,
I saw a really cool demonstration of a Navy destroyer that had laser weapons. Yeah, yeah, pretty wild stuff. That's for sure. That's interesting. Do you think that because Trump's back now, that these technologies are going to be coming out more and more easily, perhaps?
yeah,
'Cause-
we've seen a lot come out just in the last 3 months.
yeah,
So from our perspective, and this is another thing that I don't think people really understood. Um, I'll give an example. The undergraduate jet training system. This is an airplane that the US Navy has wanted to replace the T-45 Goshawk, which is a British aerospace Hawk that was produced by McDonnell Douglas. And they're on the T-45C now. And it's used as a trainer for Navy pilots.
Mhm.
And we have to replace it at some point. And so the Navy has started looking at options. And they released requests for information about different options since I think 2017 or 2018. And so Stavatti has responded to those consistently for the last, well, since essentially 2018. Well, under the Biden administration, really nothing happened with that project at all. It never got funded. They didn't go into anything. Under Trump, they just released a new request for information just on Monday. Now they had released one in August too, and we responded to the August 2024 one. But now they're putting up timelines.
Oh,
So we expect an RFP to be released in later this year. And so our goal is to try to get our prototype funded and flying and all that going as quick as we can. Now this kind of goes back to, so this is under Trump. So something's happening under Trump. He also revealed the F-47 Next Generation Air Dominance Fighter program. They made a decision on the Air Force program.
okay.
So that came out. And there are lots of things happening. And I'll give an example of what happened under the first Trump administration. They actually selected Boeing as the company to build the TX, which is now the T-7A. That program had gone on forever. We started being involved in that as early as 2009. So it took from 2009 to 2017 for something to happen.
Wow.
Well, it was under that first Trump administration that it actually happened. So from the aerospace defense perspective, the airplane deals are happening under Trump. They haven't been happening under everybody else.
Yeah.
You know, the only big deal they had was the F-35, which has been this gargantuan trillion-dollar project that has gone on, that kind of dominated the industry from 95 until the present day.
Yeah. And I can remember I asked you if you were at the meeting in October, was it 31st of 2020, when David Wilcock met with Trump directly? And I do remember asking you if you're at the meeting, and you said you were at that point. Can you talk
Well,
a little
yeah,
bit
that
more
was
about that?
yeah, that was a meeting that well, we met at the Trump International Hotel, and that was
Yes.
in Washington D.C., and we were both there in I think that was right around the 14th of October. Yeah, that was
Okay.
in October. Yep.
Yeah. Yeah. Very cool. And that's when you purchased the Niagara Falls facility, I believe.
Yeah, that was October 30th is when we purchased it. So it was kind of, it's been a challenge over the last 4 years, because it's like we bought a facility, we had political inroads, we had programs lined up, we had things happening, and then you get a change in administration, and it's a completely different policy. It's a completely different approach. And then you get wars that started, say, in 22. Well, they didn't start, but they accelerated, the Ukrainian war.
Yeah.
And we're probably the one defense contractor that hasn't sold weapons to Ukraine. And
Yes.
and that's not to say, and here's the irony: we have an office in Ukraine.
I actually know that. I know
No.
that, as a matter of fact.
So it's an interesting situation that I could go on and on forever about the politics of that. And so what are we really doing in Ukraine? And well, we haven't killed anybody, so that's good. None of our products have hurt anyone, and we like that, so we don't have any blood on our hands. But we've made some really interesting observations about this whole mess. And there's certain services that we can provide to Ukraine, and that we have. We've provided some services to Ukraine, and they've been beneficial. There's other things that we can provide in the future, but this has been a very disturbing war to us. I think we've helped a lot of people. We're still helping some people, but it's not something that, as a defense company, we're not benefiting from the war,
Yeah,
which is different.
yeah, definitely. Yeah,
So it is. So it's. But that said, the I would say that the wars of the Biden administration didn't impact us. We weren't involved. We have a different business model, and that's where we turn to a lot of other activities. But at the same time, there's some misunderstandings about how defense contracts are awarded, who is getting what money and for what.
yeah,
And so, we've taken a different path, and I think in the long run, it's going to be a lot better for us. And we didn't get our hands dirty with a lot of the mess. And the sad news is,
yeah.
and if you watch the news, um, and we saw this firsthand, a lot of the money for Ukraine did not go to the war effort
Oh,
at all.
exactly. Yeah, yeah,
Billions were misspent.
yeah,
And so one of our requirements is that if we're involved, we can't have the money misspent. And if you want to buy an airplane from us, great, but we're not gonna, it's not gonna be a situation where there's more involved than buying an airplane.
yeah, yeah, definitely. Stavatti has morals,
Yeah,
is
that's the
what you're
idea.
trying to say, basically, which is
Yeah,
fantastic, right? That's what the world
basically,
needs.
yeah. And
Um, I did have a question about your drone because you said that it's available now. Can you tell us a little bit more about that?
sure, that's the SD-10 Albatross. It's a civilian drone or a military drone. It can be used for surveillance or haul payload. And so that's an airplane that's being manufactured for Stavatti. It was it's in my opinion, it's not my favorite product in the world by any means, but it's a drone product. It goes up and down and flies and can cruise for 4 hours.
Okay.
We have a newer version that we're developing that is for civil or military purposes that will haul larger payloads and do essentially the same kind of mission.
Yeah.
Uh, but they're, it's
My best friend's a helicopter pilot, and when I showed him, the first thing he said is how much,
oh
because
yes.
he wants one, right? So how much is a civilian version of something like that?
Well, it does depend on the sensors and everything. It ranges from about $25,000 all the way up to $100,000,
Okay.
depending on the sensor payload and what it's intended to do, and if it's a military version or a civil version. We do have some pure civil versions of it that are good for uh, just a variety of surveillance type missions,
Yeah.
like power line management,
Yeah.
anti-poaching, anti-piracy type things. So,
Yeah. Very cool. Well, that's great.
on cargo. Yeah.
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 Um, Lacey, do you have any more questions for Chris?
Um, as far as the hover car goes, I wanted to ask you about the tinting systems in them. And I know a lot of your planes have the canopy systems in it. So can you talk about that a little bit too?
Sure, that ties into the canopy embedded display technology, which is really an organic LED technology that's embedded into the canopy. So that allows you to have information displayed or allows you to like have your heads up display is really the canopy at that point.
Mhm.
And that gets rid of the need for a helmet mounted sight. And when we first started doing that, the big issue was, at least with the Air Force, and this goes back to the 90s, the
Yeah.
whole idea of projecting information on the canopy. And you really couldn't do it then because of the distortion involved with a traditional heads-up display projection. Well, fast forward 25 years, and we have organic LED displays, and that solves the issue. And so there you go. And the whole idea of the having to wear a helmet with a helmet mounted display system like they have with the F-35, there's benefits to that, but also having just something that projects on your canopy that's helmet independent
Yeah.
It's good, especially in the civilian world, because you don't want to be flying or having your hover car having to wear a special helmet that costs as much as your car.
Yeah, exactly.
So, so
So
that's
safe to
that's
say that the
definitely
hover
key.
car is going to have that technology then, hey?
Yeah, that's pretty much standard, and that gets into self-tinting because you can dim the whole canopy, so or a specific area of the canopy, or that's where I think I mentioned something about artificial intelligence earlier, but
Yes.
that's really where our AI focuses upon the little fine-tuning aspects of knowing where the sun is and what you
Oh,
need to do. Like right now, we're both have windows open and we've got sunlight on us. Well,
yeah, exactly. Yeah.
if you're flying in an airplane, you can be blinded, you can overheat, you can have all kinds of things happen
Yeah.
because of the location of the sun and how it shines through your canopy. And the hover car has a lot of transparency, open, transparencies to it, a lot of windshield.
Oh,
So
cool.
you can, so the problem with that is twofold. You can be cooked by greenhouse effect
Yeah.
in the
Yeah.
vehicle, or, you can also be blinded. And unlike a car where you have a visor that you can pull down, an overhead visor you flip down, you need something more robust for this type of vehicle. And so that is a direct military technology, but it's also, it's a commercializable civilian thing. So it's pretty neat.
Yeah. Transferring over. Very cool.
Yeah.
Um,
How did the name Stavatti come to be, by the way?
yeah, that's a great question.
Yeah.
Well, it was a name we created. I came up with the name, and that's something we invented. But it does relate to our I wouldn't say our Italian heritage, but one of the first groups that partnered with us was an Italian aircraft company.
Oh,
And so we had a joint venture. We received a certain amount of money from the Air Force and also from an Italian company. And the Italian company had worked on, now it's like iteration 5 of that company, but they were one of the Italian jet fighter manufacturers that worked on the F-104. And the original idea was we're going to build a fighter to replace the Italian F-104s. So that's kind of an homage to that element. Now I've heard it's more Greek, and we're doing a lot of things in Greece, so we're happy about that.
that's really cool to know where it came from. Yeah.
One of
And
the I do have a fun story with that. I had
yeah.
a friend who's into past life regression and all that sort of thing, and I was told that in a past life, Stavati was the name of a company in ancient Greece that I used to own thousands of years ago.
Wow.
I was told that about a
Wow.
decade ago. And I thought, well, that's really cool. And then what's interesting about that is the amount of business that we're starting to develop in Greece. And it
Wow.
just kind of ties in. So
That's very,
Oh,
very cool. Wow.
yeah, yeah.
Awesome.
Yeah.
Well, thanks, Chris, for all your time. We'd love to have you come back again and tell us more about your development projects and like the SM-36 Delma, for example, and the
mhm.
hover car and everything else. Yeah. Yeah.
Well,
Yeah.
you're welcome, and I'm happy to be here. So, and thanks for doing what you're doing. All that research is great.
Yeah. Yeah.
To
Well, it's just so
explore.
interesting.
Yeah.
Mhm.
Hmm.
Yeah. Now Lacey's hooked, basically.
Yeah.
Yeah.
I'm
Yeah.
on the Stavati train for sure.
Oh,
Yeah.
well, great to hear.
Very cool. All right. Well, thank you everyone for being with us on Technology Envoy with Chris Beskar, the CEO of Stavatti Aerospace, who's come on. This is the fourth time that I've talked to Chris, and we're looking forward to more interviews in the future. And thanks again to everyone. And thank you, Chris
You
and
bet.
Lacey.
Okay.
Yeah.
Yeah.
Well, talk to you later.
Yeah. Great. Cool. Okay.